Hi there again, this is Teacher Henry. Today we're going to discuss about radicals. Radicals is simply, from a previous discussion, this is just a reflection of the laws of exponent, law 4. But this time, I'm going to discuss to you about the concept of radicals. So let's say we have here a to the m and n. Now, your a to the m here will always be called as your radicand. And this sign over here, this one, is called radical sign. Now what about the n here on top of the radical sign? We call this n either your index or simply your root. Okay, so these are the basic concept of radicals. So how are we going to simplify radicals? Let's consider first all constants. So when we evaluate radicals, okay, let's start with constants. So let's say we have square root of 99. How are we going to answer this? What we're going to do is to get the factors of this 99. Say we have two numbers, we have 9, square root, we put them in radicals, and then we have here 11. So square root of 9 times square root of 11 will give us square root of 99. But here, we're going to evaluate what is now, because this 9 here is a perfect square, and its value is nothing but 3. However, this square root of 11, it has no actual or it has no exact value. Therefore, your final answer here will simply be 3 square root of 11. The question now is, how are we sure that our answer here, square root of 99, is 3 square root of 11? This is how you're going to check your answer. So all you have to do, the number outside the radical sign, you have to multiply it by itself. So 3 times 3, and then you have to multiply the remaining number, which is the radicand here. Okay, this should have a product equal to 99, and this should be equal to the radicand of the given problem. Okay, let's have another one. For number 2, let's say we have square root of 48. Alright. So when we extract the two factors here that will give us a product of 48, there could be different numbers like 2 times 24. Let's try this one, square root of 2 multiplied by square root of 24. So both of them are not perfect square. So we have to choose factors that will give right away the exact squares of a certain number. So meaning to say the square root should be exact. Let's try square root of 16 times square root of 3. When you multiply 3 by 16, it will give us 48. Now you will notice that square root of 16 will give us an exact value, which is 4. But this square root of 3 will not give us an exact value. So it will remain square root of 3. Therefore, your final answer for square root of 48 will be 4 square root of 3. Now again, we're going to check whether our answer is correct or not. How do we do that? So we simply multiply the number outside the radical sign, 4, by itself, and then the remaining number will be the radical itself. So 4 times 4 will give you 16, and 16 multiplied by 3 should be equal to 48. If these two numbers are the same, that means your final answer here is correct. So for constant, all you have to do is to find the two factors for the radicand, and then make sure that one of which will be an exact or a perfect square. And then you subtract that, you get the square root of one number. The other number, you just have to affix it here. So that will be your answer for evaluating radicals. Okay, let's have last example. Say for number 3, we have square root of 150. Alright, so this is quite a bigger number compared to the 2. So we're going to think of two numbers. When you multiply, it will give us the value of 150, and then place it inside the square root. So that could be 25 here and multiplied by 6. So that means the square root of 150 will give us square root of 25 times square root of 6. And you know very well that the square root of 25, or simply this is a perfect square that will give us a value of 5. However, this square root of 6 is not exact, therefore it will remain square root of 6. Your final answer now will be 5 square root of 6. If we're going to check if your answer is correct or not, we simply multiply this by itself. 5 times 5 will give us 25 multiplied by the radicand here, 6, should be equal to 150. So for the 3 example I've given you, it only shows that you should not wait for your teacher to check whether your answer is correct. You can check it yourself, okay? So I hope you learned something from this lecture, and I hope to see you again in my next video. Thank you for watching once again. This is Sir Henry. Goodbye.